Good morning, guys. So this is a part of the video where I'm going to walk through the problem from yesterday. If you know that you got that problem right, go ahead and skip forward until you see me start on number 4. Okay, so let's get started on number 3. Again, you guys should know if you guys got this one right already because you checked your answer. So here, what I'm going to do first is I'm going to check if this is in standard form. That's always my first step with solving quadratics. And I know it's quadratic because it has that squared, that normal x, and then it goes on to just have those for our powers. So standard form has this written in decreasing order. Yep, it goes x squared, x, and then the normal, and it equals 0. So that means I am in standard form. And that leads me to my second step, and that's labeling my A, B's, and C's. So I write out the standard form of the quadratic formula right underneath the main one or above. And I'm going to just figure out what each of these things are. Well, the A value is what's in front of the x squared, so that's 2. The B value is what is in front of the x, and I circle the sign 2. And since there's nothing there, but there is a plus sign, that's plus 1x. And for C, I have a negative 10. Don't forget your negative here. If something went wrong, it could have been that you lost your negative. So our next step is to fill in the quadratic formula. Now, I'm going to just fill it in as I go. So here I'm going to have a negative b, so negative 1, plus or minus the square root of b squared, so 1 squared, minus 4 times a, which is 2, times c, which is negative 10. And I have some hidden parentheses here. Next, all of this is over 2 times our a value, which is 2. Okay, so I'm going to simplify and solve. I'm going to start inside the smallest parentheses, which is this one underneath the radical sign or square root sign. This is 1 squared, or 1, minus 4 times 2 times negative 10. Well, 4 times 2 is 8, and 8 times negative 10 is 80. So since this has a negative, this turns into a positive 80, and we have the square root of 1 plus 80 underneath the radical sign. And this is 2 times 2, or 4. Now I'm going to simplify still inside of here, which is 81, and I'm going to take the square root of 81 in one fell swoop. That is 9. So I have negative 1 plus or minus 9 over 4. When I split this up, I end up with negative 1 plus 9 over 4 and negative 1 minus 9 over 4. Because again, I can't solve this together. I do need to split it up at this point if everything's simplified until then. So negative 1 plus 9 is 8, and 8 divided by 4 is 2. So that's one answer. Negative 1 minus 9 is negative 10, and negative 10 divided by 4 is negative 10 over 4. Or you could do negative 5 over 2, or 2.5, and again, that has to be negative. If you put this in and it didn't work, double check that you used parentheses around your number, because if you don't use parentheses around a negative number and you square it, it will give you the wrong answer. Now, if you've been paying attention, you might notice that this is a problem that I did before. So if you had gotten stuck, you could watch one of the previous videos, which you should have done to help you, and realize that this is the one that I did on Monday. And that's okay. It's good to look back at your notes so that you can get some help. And sometimes, guys, I put the same problems there because I want you to have some rewards for going back and checking how I did the problem. And if I end up walking you through one, like, more power to you for taking the time to look through what I've given you to help. All right, so let's look at numbers 4 and 5 because these are still quadratics. And the reason why I know that these two are quadratics is because they both have squares in them and they have no higher power than that. Now, if I want to solve a problem like this, I have a slight issue. This is not in standard form. Now, I could rearrange this problem as much as I wanted. I could write negative 3x plus 2x squared is equal to 8. I could move the 8 over and the 2x over, and I could have negative 3x minus 8 is equal to negative 2x squared. Now notice that, like, everything I'm doing to move these around is keeping this problem balanced. So I'm totally allowed to move my terms around and still have the same equation in terms of equality. So because of that, if I'm trying to solve this and the only thing that's standing in the way is that it doesn't look like the previous ones, the first thing I should ask myself is, can I make it look like the previous ones? If what's throwing you off is it doesn't look like that, ask yourself, how do I make it look like that? Well, let's just look at this one that I did right here. Well, all I really need, or what, we'll go back to the main one. All I really need is to have the 8 over here. And I can move an 8, I can move anything in an equation just by undoing the operations around it. So I can subtract 8 from both sides, and that leaves me with 2x squared minus 3x minus 8, right? I had to subtract it to move it over, is equal to, well, 8 minus 8 is 0. And we want a 0 there, right? Because standard form is ax squared plus bx plus c is equal to 0. So you can see I now have this in standard form. And by the way, sometimes you're just going to be flip-flopping like the x squared and the x. They just get like moved around like I did over here where I maybe had to swap them. That's okay. You can just move them around. If they're on the same side of the equation, remember that you're not undoing it. You're just flipping them around. So this one, I could have the 2x come in front, or I could have the negative 3x come in front. Doesn't really matter. As long as I keep the sign with the value that I'm moving. And you can always do that if it's addition and subtraction. But thankfully I didn't have to do that here. So if I have this as my starting equation and it's now in standard form, that means that I can still solve this, and what I need to do is find my A, my B, and my C. And again, I can do that just by circling. Now I fill in my quadratic formula. So here I've got a negative b, so negative negative 3, which I'm just going to write as a positive 3 right from the get-go, plus or minus the square root. Okay, now I know that I'm going to do b squared, which is a negative 3 squared, but I know that a negative and a positive squared are the same, so I'm actually going to write a positive 3 in here so I don't forget that, because remember, if I square it, that negative is going to disappear anyway. We've been having a lot of calculator issues where you forget to use parentheses around something where you square. If you know that you do that and you're squaring it, you can just turn it positive right now so you don't forget later. But only do that if you're squaring things. So minus 4 times our a value of 2 times our b value of negative 8. All of this is over 2 times a, and I'm just going to do that right now. 2 times a is 4. So notice I'm doing many simplifications as I go. I'm keeping the core of it the same, but little things I can kind of simplify. So here I have 3 plus or minus the square root of, well, 3 squared is 9, and see how I have a net minus and then I'm going to be multiplying a negative? This whole thing is going to turn into a plot positive because this negative and this negative are going to cancel out. So 9 plus 4 times 2, which is 8, and 8 times 8, or 8 squared, 64. Now this is over 4. 9 plus 64 gives us 72. So that means that we have 3 plus or minus the square root of 72 over 4. Now when I take this in my calculator, I'm going to take the square root of 72 real quick. So the square root of 72 is equal to a decimal value. Now decimal values are not inherently bad, right? It's just a number. So I have 4, 8, 5, and I want to keep it long enough that I'm getting enough of the digits in there and rounding this last digit 5. So because 2 is of course less than 5, we're rounding down. So I have 3 plus or minus that value all over 4. Now this is where I split my problem, right? I've got 3 plus this answer divided by 4 and 3 minus this answer divided by 4. So the 3 plus the 8.485 over 4 is equal to, well, let's just check it out. 3 plus, and I'm just going to use second answer or I'm not because I clicked the wrong button. Second answer, and that uses this if you want to use a shortcut on your calculator. I'm going to hit enter so I get this answer first, because remember you can't type it all in at once without parentheses or it will give you the wrong answer. And I can divide that by my 4 to get 2.871. That's my first answer. My second answer will be the 3 minus the 8.485, and again, parentheses around that top. I know this is getting a little bit messy, sorry about that. So I'm going to do 3 minus, and I've got 8.485, there we go. Divide that answer by 4, and I end up with a negative 1.37. Okay, I am going to quickly check these answers by putting them into my original formula. And in this case, I'm going to want them very close to the value of 8. So 2 times my first answer, 2.871 squared, minus 3 times 2.871 should be equal to 8. Now this is not exactly 8, but remember that we rounded, and I'm within a 0.5 decimal place away from my answer. So that means I'm probably correct. Now I'm going to do the same thing, only with my negative, and I'm going to use parentheses every time I type in the negative number because you want to make sure that it doesn't lose that negative, okay? So I have this, it's squared minus 3 times, and again I'm going to use parentheses because I don't want it to lose that negative. And does that equal 8? Well, it equals something really, really close to 8, so that means I am probably correct. In fact, I am. Now, sometimes you're going to end up with problems where it doesn't seem like you have enough information. Well, if I look at this one, I'm looking at this and going, okay, well, this is not in standard form. So I'm going to try to move things around. I'm going to start by let's just subtract the 4 from both sides. That's going to give me an answer of x squared, writing this in the wrong spot, x squared, well, this will be minus 1 is equal to 0. Oh. Well, notice how this one doesn't have a second x. I don't have a normal x in here. You know what that means? That means I don't need to use the quadratic formula because I can isolate this. I can get this all by itself and solve for x a simpler way. So I'm going to do that. I'm going to just get this by itself. Plus 1 to both sides will move things away from my x, leaving me with x squared is equal to 1. And if x squared is equal to 1, I can take the square root of both sides, do the positive or negative. That means that x is equal to the plus or minus the square root of 1. And since the square root of 1 is just itself, x is equal to plus or minus 1. So I have two values that x could be. It could be a positive or negative 1. And again, I can check that. I can put it in and double check. It's okay to be missing a variable, and if you have it where you don't have an x, please don't go all the way through the quadratic formula. You'd put a 0 in front of for b value if you were going to do the quadratic formula, and you just find that yes, it will give you 1 or negative 1, but it will take a really long time to give you that when you could just get the answer using normal simple solving, okay? So be smart about it so that you don't waste your time. Could you use quadratic? Yes. Do you need to? No. Another quick thing to note, and I'm just going to add this as a final note right here. Let's say that you're solving something like this where you have, let's go with 3x minus 4x squared is equal to 0. Now in this case, we would want to write this in standard form. So I'd move that 4x squared to the front. Notice I'm on the same side, so I'm not having to add to get rid of it. I'm just switching its position. Plus 3x. And I don't have another value here. That equals 0. But in our standard form, we usually have ax squared plus bx plus c is equal to 0. Since there's nothing, like literally nothing here, that's a 0. So anywhere that you would normally write c, you'd actually write 0. And I'm not going to solve this one. I just want you guys to see how it works. Okay, so that is it for today. Tomorrow we are going to practice a few more of these. And all I want is for verification that you watched this one You know what? Nope, never mind. Today, this is all I want you guys to do. I left my English kids a lot of work to do, so I'll save you guys a little bit of time on math. Have an excellent day. I'll see you tomorrow.